Hey folks, and welcome to this week's News and Community Spotlight. Welcome to the future of animation. The celebration begins Monday, June 27th, and the week will be packed with highlights from the Annecy International Animation Film Festival, real-time techniques, insider stories, case studies, and a brand new animation field guide. Head over to unrealengine.com/future of animation and sign up to get all the content straight to your inbox. Students rejoice! Submissions are now open for the Fall Student Showcase. This is your chance to get your work in front of thousands of people. Potential employers, high-profile developers, VFX supervisors, you never know who's watching. Submissions close Sunday, August 7th. For more information, head to unrealengine.com/student showcase and be sure to check out unrealengine.com/students for even more student goodness. Unreal Fest is coming back to a live audience in North America this fall, and we want to hear from you. Have you made something you're proud of with epic tools such as UE5, Twinmotion, and MetaHuman? Then share it with us via the Call for Proposals form, which includes complete submission details. Open now through Friday, July 8th. Want to look inside the development of Beyond the Grave's Return to Scumland? We recently spoke with Korean developers Iggy Mob and Blueside on how they revived the decade-old franchise, what to expect from Grave, and the impact talented artist Akuma Nakamura had on the game. See the full interview on the feed and get a scoop on how UE Technology helped develop the look and mechanics of Gungrave Gore and the impact of an epic mega grant on the game and the studio. Swinging over to this week's Community Spotlights. Embark on a VR journey as an adventurer arriving in the Lonely Mountains in Grimlord, an action RPG based on the physics-driven combat by Metal Cat Studios. Players venture into dungeons using a vast number of player-tailored weapons while squaring up against enemies and bosses to help a lord in chains return to his kingdom and lay vengeance on the tyrannical Grimlord. Wishlist now on Steam. Made in UE5, Ryan Johnston brings us this mystery-soaked environment design project. Callington Manor is said to be home to a sorcerer, and others say the manor is haunted. Either way, I think we can agree on how beautiful this environment is. Let them know what you think on the forums. Looking for a dangerous adventure? Or perhaps glory? Xinhuan has done a fabulous job at sculpting the atmosphere that will make any adventurer excited. Saddle up and journey to the desert ruins on their ArtStation page and let them know your thoughts. Catch you next week, and thanks for watching.
Hello everyone, and welcome back to Inside Unreal, a weekly show where we learn, explore, and celebrate everything Unreal. I am your host Tina, and today with me I have the incredible guest Philip, and I am so excited to dive more into your project and the stuff that you brought today, but we do have a couple of quick announcements first. So first up, we are still doing our lighting challenge that ends this Sunday. So if you haven't completed turning in your submissions, make sure that you get those put in by this Sunday. Again, you can find all the information about that on our forums, so make sure you go check that out. The other thing is that we have Unreal Fest coming up. It is going to be live and in person this year. It will be taking place in the fall here in the US. And if anybody wants to be able to put in a proposal for being included in Unreal Fest, you can do that by following the link that we'll be dropping in the chat. So make sure you check that out if that's something that you're interested in doing. But with all of that aside, I now would like to formally give over the floor to our guest, Philip. Would you like to tell us a little bit about yourself and the project you brought for us today?
Of course. First of all, thank you for having me. It's great to be able to talk about the work that we're doing with such a big and such a specific audience. And I hope we have a good conversation for the next hour or two. My name's Philip. I'm the CTO and co-founder of Y-Drive AI. And Y-Drive's mission is to build a sustainable real-time digital twin of our planet. What that means for the gaming community and what's sort of the question that we're going to try to answer tonight is, what will it take and when will I be able to build GTA-style open world levels with just my phone? When can we expect to have this tech in hands of developers and not just AAA studios? So that is our topic tonight, and I hope we have fun.
Yeah, I
So
am so looking forward to it.
before we dive any deeper, I just want to thank Epic for awarding us the mega grant. It's really been a leg up for all of our development efforts in the very, very beginning of Y-Drive, and not just financially, but also as a morale booster. Like having somebody as big as Epic say, "Hey, you guys are not just smoking crack. This makes sense, and we'd like to support you." Really felt great, and the relationship with Epic has been amazing throughout. Uh, being a grant recipient from other sources just tells me about. I just want to be open about how streamlined and elegant the whole relationship with the Mega Grants team has been, and I really encourage everybody with a cool idea to apply and get support. Right. So stepping back into what Y-Drive's doing, I'm gonna start a bit broad before we sort of nail down on the actual technology that we're bringing to Unreal Engine, or that we're working on to bring to Unreal Engine. So, like I said, Y-Drive's mission and vision is to have a digital twin of our entire planet, which technically means, and I'm going to trivialize it a bit, but I think it's going to help the discussion, having a huge 3D model, an incredibly high poly 3D model of the planet, say at 5 to 10 centimeter resolution, updated weekly. So not real time, but let's say we want to have this this huge thing updated every week. And now the question is, how will we go about doing that? That definitely sounds like a moonshot. So for any kind of moonshot, you sort of want to look at a few smell tests. Like, is it barely technologically feasible? Is it useful? Is it presentable? So when we're just being tech geeks, imagining a product like this, it definitely sounds cool. So it passes sort of the interesting and cool bar, but would it be useful? Would it be useful to say have Google Earth at 100x resolution updated weekly? And I have to say it does feel so. So if you look at some of the applications that something like this would have today, definitely navigation, moving from 2D maps to 3D, taking you, showing you where to park, showing you where the door to your destination is, would, transform some of the applications we have today. On the other side, say the construction industry, which isn't so cool and interesting, would have amazing use for this tech for inspection, etc. Simulation world would definitely benefit from something like this in both, say, logistics, robotics, etc. So there, we can sort of see a set of applications that this kind of product would have in today's world. But what's really interesting is, what would people come up with if we were to build this? So what are the applications that would emerge once this kind of tech is available? So going in deeper and just looking at it from a practical perspective, what we said is a 10 centimeter resolution or a 5 centimeter resolution mesh of the entire planet. If you do some just back of the envelope math, it would take about 10,000 terabytes to fit something like this in memory. And that is, it's a lot, but it's reasonable. 10,000 terabytes is 1,000 10 terabyte drives, which are $299 at Best Buy. So, passes the sniff test on that one. Even if we're off by 100x, it's still affordable. So we can, we have enough hard drives to fit this. Could we render something like this? Again, some back of the envelope math. If you want to render a very, very intense scene of a city, that takes about 32 gigs of VRAM. So, okay, today's GPUs could show this. And that brings us to the maybe the hardest question, and the one that we're going to talk about the most, is how do you collect this data? Like, how do you get the entire planet once a week. And then how do you convert that data? Like, what is the magical black box that converts this from obviously images to models? And I think that is, like, if we dive into this problem, that is where we're going to find a lot of intersections with what we could bring to developers through Citizen. Now, just thinking about this amount of data, there are basically two kinds of devices that are scanning the world regularly. That will be cars equipped with cameras and phones. So we have about 2 billion cars. Today, not a lot of them have cameras, but that fraction is growing. So cars are one option. And the other one is phones. We obviously have more phones than people on the planet today. We would, yes, we would have to take the subset that are attached to a single person. So cars and phones come up as sort of obvious solutions. There's the obvious questions, well, what about satellites and aerial? And the answer, which sort of puts satellite and aerial generally in the backseat, we're not discarding it, but we're putting it in the backseat, is because for the kind of applications that we need and the kind of resolution we need ground level imagery. So you can't really get quality signage from aerial. Not to talk about scale, just comparing the number of drones and the resolution of satellite imagery to everything I talked about before. So just looking at data sources, we have these camera-equipped cars, and we have phones, and that we can sort of squint and see, and see that we can get scale in urban areas, which is fine. We can focus on urban areas for today. Now, when it comes to this magical computer vision black box that converts images to models, that is where things get tricky, and that is where sort of Y-Drive's approach is different and much harder than what everybody else is doing. So in computer vision, which is, again, trivializing a bit, let's say computer vision is opposite of graphics. So in computer graphics, you have a model describing your world, and you're creating an image. In computer vision, you have an image, and you're sort of trying to explain the world from it and build a model. When you want to solve a problem using computer vision, you typically want to control the hardware that does the capture, so that you get images in a standard and in a form that are best suited for your algorithm. And then the algorithmic side is much easier. It's not easy, but it gets easier. And most of these problems are very, very hard. So you want to help solve it from say multiple fronts. And we can typically see that with any mapping company doing mapping with specialized equipment. If you take a look at the Google car or TomTom cars or anybody else who is very fleet heavy, they have very, very specialized equipment which is designed for this very purpose, capturing images of the planet. Now, the reason this approach doesn't work in our case is because of the 7-day update ratio. Like, if, again, back of the envelope math, if you have one vehicle in a city, for a city the size of San Francisco, it takes about a month of driving to update it. Now, multiply that by the number of cities on the planet, and the answer becomes obvious, sort of. If you're a company with very deep pockets, you can do this often, but you can't do it often enough to get to the 7-day update period. So that brings us back to what we're trying to do with phones and saying, okay, so we're sort of married now to these mobile devices, which we have no control over. And we just have to develop algorithms that are going to work with whatever kind of crap we throw at it. So what What Y-Drive has been working a lot on is uh, not getting the best out of phones. So the way you capture an image with a phone and the kind of camera you have on a phone are not defining the image quality that you're going to get from it fully. So we're working to educate users and to make their capture experience as simple as possible so that the data that we get is as suitable as it can be for what we're trying to do. So we have an Android app which does a lot of camera magic, but a lot of user feedback, just telling the user you're not doing things right. You should do this. You should capture with less vibration in more light, just so that the output that we produce can be as good as it can be. So basically, give us the best thing you can, and then we can work with that. And I think, just speaking about the data collection and the way we capture images with phones, I think we have a video that can illustrate this a bit better. It's a video number 1. Hands with us.
For sure.
Oh, sorry. We skipped past this. We can go to the third one, actually, right away. These are some of the results you'll see later. Right. So this is what data capture looks like. I mount my phone on the dash. It has to be just as high up on the windshield as possible. The app tells me if the phone is aligned well and if it's shaking too much, if I'm hitting a lot of potholes. I press record, and that's pretty much it. You're mapping the world with Y-Drive. You're helping build a scalable real-time 3D model. So as I drive, I'm basically getting feedback on vibration, which is very important. If the camera is shaking, we get blurry images, which are quite useless for what we're trying to do. So we can automatically discard those, and the user can know if the images are okay. You also have a map view, so you understand which areas you've covered or which other users have covered. And of course, we keep a little window to let you know what you're filming. Please never play with your phone and drive. Do all of the handling while parked. So here we're just, going for, say, a kilometer drive, capturing some data, and finally stopping the recording. We're gonna see the recording show up in the gallery, and that gets uploaded to Y-Drive's reconstruction service. Now, what you didn't see here is what is happening in the camera control in the backend. So in order to get images which are perfect for computer vision, those same images are not perfect for humans. So these phone pipelines are optimized to make images that look nice, but what looks nice to us is not the greatest thing for machines. So we do a lot of processing and control in the background just to make those images at the peak quality that these phones can bring. And once again, what you saw right there is a mid-range Android. It's a $200 phone. So we're staying away from anything specific, such as iPhones with LiDARs or high-end Androids. We want to be able to cover the biggest user base that we can get, that's physically possible to help us create quality 3D models. So
incredible. Like I'm just mind blown by the idea that that's on. First of all, I feel called out for my crappy Android, but it is good to know that the software could work on, not something that's necessarily super expensive or out of reach for most people.
Exactly. So that is that was the driving behind our thinking about scale. We wanna be able to capture billions of phones and use them to contribute to this huge model. Now, developing this tech, we realized that okay, we can take parts of it and say enable a game developer to use his phone and our service to build, say, a racetrack around his neighborhood, which sounds pretty cool. And that is sort of the practical approach that we're gonna dive deeper into today. Now, also keep in mind when we started this journey, we really didn't have games in mind, and none of our team members are game devs. So what we'd like to use this opportunity to get feedback from people who are in gaming to tell us, is this useful? Like, can you do something with this? Are we barking up the wrong tree? Just any feedback we get today, anything we learn from this stream is actually very useful. So
Awesome.
with that in mind, I think we can go on to the next video, which is going to show the sort of quality of the mesh that comes out of the process that you just seen. I think this is sort of the exciting part. So what you can see here is that due to the field of view of the camera, we sort of have limited range upwards still. We do have some, holes in the mesh, and those are sort of the things that from an alpha to a beta to a released version tend to improve. The texture quality is probably something that we can improve much more, and where the actual limitation of the Android cameras comes into play. And finally, I think I'm talking about the bad parts off the bat, and I'm going to skip into the good ones, is just PBR. We had some ideas about PBR when we started Citizen, like how to make these textures actually feel natural, which didn't initially pan out too well, and that is something that we're still experimenting with. We do hope that this kind of mesh can be physically rendered as well. Now, on the positive side, a lot of the issues you might see right now can be touched up by either manually or just by effects in Unreal, and we'll see this mesh in Unreal in an actual application a bit later. And also on the I think very positive side, this was made from 600 images and took about an hour to process. 45 minutes to process, which if you're sort of in the photogrammetry world, I guess you could say that the output is on par with what's out there commercially. But I think when it comes to just ease of use and computational time and the amount of data, that is where we're really pushing the envelope. Like, you don't need specialized teams or specialized equipment or trained users. Just put the phone on the dash and drive around.
I mean, sounds like even I could do that. So.
Yeah. My mom does a lot of mapping for us.
Oh, that's perfect.
She's 60. Yeah, she's 65. So yeah. With CitySynth, now so far we just show you, a mesh coming out of a reconstruction algorithm. With CitySynth, what we really wanted to do is optimize these meshes and bring them into Unreal and optimize them for actual game use. So we can take a look at the next video to sort of show you what the process looks like. So our private preview users would basically get an email with their reconstruction results, which is a folder with a bunch of pack files. You open it using the CitySynth plugin, and what you get is just this number of assets showing up in your workspace. Assets are quite standard, textured meshes, in UE format. We can take a look at some of those. So this is one of the building blocks without texture, so you can sort of make out the cars and the windows. We have the RGB textures, which are looking good, but not yet fully optimized. And then we also have the semantic textures. Our pipeline is able to recognize which part of the mesh belong to different classes, such as cars, roads, buildings, etc. And finally, you get your loop-to-loop, which we're gonna place here in this valley. You can zoom in and play around. You do want to align it with the ground, and I think this spot is not ideal, and we're working to do sort of a mesh/ground landscape alignment a bit better. And now that you're here, you can sort of fiddle around a bit with the light, with the skybox, just to make the environment feel more natural and resemble the environment that the mesh was captured in. As you saw previously, collision boxes are in order, so we can drive a car around, which is what we're going to do a bit later. Right, so we're going to put in a vehicle, place it in the right direction, and we're going to add a player that's going to drive the car. So on the Unreal Engine side, there is really not much that we're adding in terms of user experience or any learning curve. You get a set of models that you can use within your project. This is an attempt at PBR, trying to blend our meshes with Megascans models, but maybe we can keep that story for later and just talk about the experiments we did, because I don't think we've fully solved that issue. Right, that resembles the morning I captured this video on, and then you can get in and drive. Now we'll keep the driving video for later. Right, pan around a bit. So I think it's worth just to skip to the next video where we just do a fly around to show how the mesh looks from different angles and what it appears like in Unreal Engine. So this is sort of a high quality cinematic render. We can again see how it looks from a slightly different camera than the one we used to inspect originally. And then you can see how the unlit colors sort of blend in with the rest of the scene. And this is where I like to ask somebody who is a game dev, is an environment dev, like, is this something that you could build on top of? Like, is this a base for something where you could say, okay, I can spend some time here and add it my personal touch to have it look like the way I want it artistically? Or is it just a rough draft for, say, building something from scratch? And that's an honest question.
I think it's a good one. I can say, at least from my experience, I would believe that would serve as a great reference and at least a good baseline for size comparison, layout work, all sorts of things like that. But I'll give the chat a second to catch up because I'm sure there's going to be some thoughts on that. The bits that I do see so far is, yeah, a lot of people agreeing that it would be great for reference, really good for having correct scale, really a good baseline to work with. And it's so fast. Instead of having to set up your own individual scaling references or trying to come up with a layout through different phases, you could just find an area that you like, or even something you'd like similar to that, and capture it all right there on your own phone and have the perfect scalable baseline to work with, which is, I mean, honestly, kind of groundbreaking for especially things like indie studios or solo devs. I can definitely see the value of having something like that available.
That's actually a very, very useful point. Um, just being able to, if I understood correctly, I'm just gonna try and paraphrase what you said, is if you're in a place that you like to capture, um, you could you wouldn't have to remember what it looked like or just take a few pictures. For reference, you could, drive around or walk around with a steady hand, and have actual scale and reference for your future work. That sounds actually really cool. Thank you.
Yeah,
Uh,
absolutely.
so what we also prepared is just a quick video how this might look in a racing game. So you have a full loop with the view from inside a car and audio. It's not too impressive, but it was put together end to end in, I think, less than an hour. So that might be another metric that could be useful here. Dan, could you please play that one for us? I don't have much to say here except that Nicola's doing an awesome job driving. I don't know how much he practiced this. He says that he did it from the first try. I don't believe him.
Oh, no way.
Yeah, he must have practiced.
That turn is too smooth. I call crap.
Yeah.
Awesome.
And he's also told me that he unintentionally parked in front of the "Say No to Vaccine" graffiti.
Well,
Right. Yeah. So I think that sort of covers the state of current development on Citizen when it comes to the, say, traditional rendering pipeline, like a magic computer vision box that takes in images and throws out meshes and puts them into Unreal. Now, it wouldn't be 2022 if we didn't sprinkle some of the magical AI fairy dust on this to make it look better. So I do have to. I'd like to show some of the previews of our work on the non-traditional rendering pipeline, which sort of has some AI elements within the rendering pipeline that make all of the output look much more photorealistic. Like the whole workflow still feels very much the same, but when you look at the output, it sort of has this photorealistic layer on top. But without me talking, like the videos were number of frames times 1,000 words. So this is basically the same model you've seen before, with a custom rendering pipeline with a lot of machine learned elements, which lets us produce this sort of photorealistic, much more full image output. And I would have to say this is sort of maybe a preview for Citizen 2, given that the rendering pipeline is completely custom. One thing that is a challenge for us, but I also think for the rest of the industry is how do we fit something like that into Unreal and make it part of the standard Unreal Engine workflow with just a rendering flag that says Ultra View or whatever marketing term we come up with it. But I'm pretty sure you can see, the delta from the previous one and what you're seeing right now. And a lot of feedback that we get from people is that when we show them these videos is that they don't believe that it's not captured by a camera. So that's why we have the disclaimer at the front, and that's also why we have the camera flying through vehicles and objects so that somebody doesn't, think it's a drone video.
I love the fact that you had to have proof. This is too good.
Yes.
You're lying.
Yeah. Exactly. So I would. So my CEO has been very sort of cagey about this part of the tech, and I've, on the other hand, would love to sit around and yap about all of the details on how exactly do we do this, because it's really a lot of fun, and it's quite advanced and interesting. But I'm just going to respect him on this one and wait until we actually launch a product. But that is something that we have in store for maybe 6 months or a year from now in this same podcast, hopefully.
Yeah, there we go. You've said it live, so now you're locked in.
Oh yeah, I have, and it's going to stay up on YouTube.
Exactly. So I can always reference back to this. Be like, you said in 6 months to a year.
Well, my team is actually who's sweating when I say 6 months to a year.
No pressure, except now you have a deadline.
And I also want to thank the Y-Drive team. You guys have been awesome. Just putting together some of these last-minute demos has been a stretch, and thank you on live TV.
Yes, huge shout out to all the incredible devs at Y-Drive. I mean, just the bits that you were able to show us of this is incredible tech. And I can see how this applies to so many different fields, like you were saying, and not just game dev either, but maybe architecture as well, visualization in general. It's a really, like I was saying before, it's a good baseline to start a multitude of different types of projects off of, with a phone that you can just bring with you wherever. Maybe you're on the way to the grocery store, you just record your walk there, again with a very steady hand. Maybe get one of those chest shock mount things so it's a little steadier.
Perhaps. But we've been working on the handheld side as well, and I think that a person with a reasonably steady hand can do it. But it's interesting when you think about the applications. One of the challenges for us as a tiny startup was figuring out, like, expanding the diamond of application and then coming down to something that we have to really focus on. That's been, ever since we started, that's been a challenge. So the good part is that the tech is 95% the same for every sort of application that we think of. So whenever we don't know what to focus on, we just focus on the tech and let applications come on their own.
Yeah, absolutely. I feel like that's the best way to build. Adds a certain level of longevity to the project.
Exactly. Yes.
So I have a couple of questions for you. And by a couple, I just mean a billion. And I will make sure to sprinkle in some from our chat here as well. But I want to know what some of the initial motivations behind making this tech were. If you don't mind talking and elaborating on that a little bit more, because obviously it's just so cool. So I really want to know what the initial thought process was, why this was specifically what you were going for, and if it was always the idea to make it This, it's not exactly the right term for it, but low tech, more accessible to the general user.
No, actually, that's a great question, by the way. When we started out, we were passionate about autonomous vehicle technology, so self-driving cars. And one of the bigger problems in self-driving is high resolution, high density mapping at scale. So the way AV companies do mapping today is high end, but sort of slowish and not very scalable, which is the right way to launch, a first set of vehicles. But once you want to have your autonomous vehicles driving around everywhere, you sort of need that world scale. So the initial motivation was building high resolution maps for self-driving. Now, at one point, we sort of saw that the tech that we're building doesn't only have applications in autonomous vehicles, and that maybe even that market is not the closest one to today, basically. So we thought about how we could expand it, and then we discovered this whole other set of problems that could be solved with the same tech. So initially started trying to solve autonomous vehicles, map the world for them, and then saw that okay, we could scale this up more and achieve actually much more and reach many more markets.
Yeah. So, and happy accident. That's what I'm
Yeah,
hearing.
very happy accident. Yes. And
Yeah.
in my previous life, prior to Y-Drive, I was working on computer vision problems which required specialized hardware. So AR drones, etc. And my philosophy was always you want hardware to help you as much as you can. Working with commodity hardware is a pain, and you don't want to do that ever. But my mindset sort of shifted towards these harder problems as we went along.
Yeah. Which I think, I mean, again, I'm just gonna sound like a fangirl at this point because it's just such cool technology, truly and sincerely. But before I get ahead of myself, do you mind if I throw a couple of the questions from chat at you? Because they've got quite a few good ones that they've got here.
Yeah, of course.
Awesome. So, some of the ones that I saw were questions about potential future plans. So, for example, obviously things like license plate numbers or certain graffiti, like we talked about before, things like that. There may be certain textures that people wouldn't want included if they were going to bring this into a game or some kind of base project. Would there be any plans for auto filter systems, or would that be more so up to the user than the program itself?
Well, that's actually a great question and a very, very important one. We actually believe that privacy shouldn't be solved by policy, but by tech. And what that means is we as Y-Drive, as a service that builds models from images, doesn't want to even handle the obfuscation on our end. We want the images that come in to be obfuscated on the device. So license plates, names, graffiti, we don't care about those. We intend to put all of that logic on the device, on the user side, so that anything we get is not a matter of policy, whether we're gonna use it or abuse it. It's just going to be a matter of technology. We're not going to be able to see anything that we're not supposed to see.
That's awesome. So and that would make things a lot easier for many people on their end too, not having to go through and scrub every single plate number, things like that.
Exactly. And on the phone side, we plan to open source the app so that this part is completely trustworthy. And you can see that, the images that are coming our end, what do they look like, and what we see on our side. because again, we're not a spy company. We're a computer vision company. We just want to make your lives as a dev easier.
Yeah. That should be on any merch that you have. Is not a spy company.
We're not a spy company. Yes. I just want to mention. I saw a note here. There's a YouTube channel by I think Ivan Savic or Igor Savic. His handle is ISAVIC. He's a dev from Serbia who's been doing something similar to what we just saw, but using commercial software and a very manual process. But what's really cool is that his output is very high quality. He has tons of views. And he also does these tutorial videos where he explains how he's making these maps. And if you sort of want to see a sneak peek at a deeper dive into our tech, I could say that we're doing most of what he's doing, but it's automated. So a shout out to iSavage. I've never met him, but I love his work.
We'll have to make sure he sees this.
Yeah.
Start a connection there. That's awesome. Especially the idea that it just automates the whole thing. I really truly do love the idea of just all of the hard work being done for me. I don't know if that makes me a lazy person or just ready to jump into the future. I think it could be taken either way, but
well, I think it makes you a pragmatic person and a focused person. So if you're already learning and if you're very deep into Unreal Engine, requiring you to learn another skill and then spend your time on another process is just redundant. Our philosophy is you should do what you're best at, and then we'll provide the rest of the process that we're good at.
yeah. So it just makes a perfect format from beginning to end. So we can get to the end product faster and of higher quality ultimately.
Yeah.
Absolutely. I love that. And I will remember this. Nobody can ever call me lazy ever again. I am pragmatic and focused.
Exactly.
So, for using this software, would you say that it's better used in exteriors or in interiors? Or would you say about the same
Oh,
for
it
both?
yeah, it works only for exteriors right now. And there are a few reasons for that. I can go through them. We're really not focused on interiors at all because we believe that market is a bit crowded, and Apple's doing amazing work on the interior. The reason we're interested in exteriors is that the barrier to entry when it comes to data capture is much lower. Capturing interiors in a way that is friendly for computer vision is an incredibly hard task. And just teaching users how to do that is something that has been tried before. We have tried it before as well. And it seems too hard to ever solve in an elegant way. I hope Apple proves me wrong. Probably there's one company that could do that. It's Apple, but that is one of the drivers that we're focusing on the outdoors. As you saw, you just mount a phone on your windshield and you're good to go.
Mm-hmm. Yeah, which is just so cool. When it does come to capturing the stuff on the outside, then kind of just expanding further in that, would you say it's better for more rural areas, more urban areas? How would it affect things like high-rise buildings or more natural, more trees, more foliage, things like that?
Well, if we're speaking strictly about the traditional, building a mesh pipeline, range can be a problem. So say we can reconstruct things that are up to 50 to 70 meters away. So very open areas do tend to have limited range. Also, foliage is not amazing in these methods. I mean, you saw sort of the lollipop trees that are typical for photogrammetry pipelines. But when it comes to the next gen TrueView pipeline, we really don't care. What it finds hard are skies and clouds at this point. But high rise, anything far away, we're getting very, very good results with.
That's awesome. How far out has the largest test been? So, for example, if you have a city located next to a small mountain range, for example, would it catch any of the mountain range in the far background, or is it going to focus on just what is closer to the capture point?
Well, we sometimes far out ranges are okay. We sometimes even capture clouds when the pipeline sort of thinks that the clouds are close enough. But something that far away typically doesn't work. But mountain ranges are fine.
Awesome. That's very cool. Very versatile.
For very tall buildings, what we are thinking of is combining ground level with drones. There is just physically no way for the way we mount the cameras and the type of cameras that we use to capture the ground level very well, and then also the tall buildings. It's just physics.
Yeah, that's really cool. Yeah, that was actually kind of a follow-up question that I was going to have because I noticed that obviously most of the demos that you showed was going forward, going across the horizon. Is it possible to also do a vertical scan going up and down, or is it recommended to kind of follow horizontally instead?
So what is important and what we sort of optimized for is that you move in a linear sequence. So we can't just throw it a set of images and have it build models. But as long as it's a video that is moving left to right, front to back, up down. Actually, lateral motion is much better than forward motion for what we're doing. Forward motion is the most difficult one. It's going to work fine. So if you really want to put a phone on a drone or just capture images with a drone going upwards, scan a building, yeah, that should work fine.
That's awesome. Very cool. I feel like drones would maybe possibly get some slightly better images than some of us could, but
yeah, I mean, drone images are great for getting scale, large cities from very high above, and also the images that drones capture have high field of view, a lot of overlap, which is awesome for photogrammetry. But the one problem they do face is they can never go down to street level, so we do have to augment it with phones.
Yeah, that's a good point. To get the full spectrum of height there, yeah. Would be a little hard to bob and weave a drone in and out of maybe some poor pedestrians just trying to go about their day.
Yeah, well, I've seen some pretty good drone pilots, but that wouldn't be okay. I can also recommend the iSavage YouTube channel. He's done multiple experiments with drones, and he actually does GoPros on a bike, and he puts them together in Bentley context capture. He's had some very good results over the years. If you're interested in drone images.
Awesome. Good to know. There we go. We've got a couple of great resources here today.
Yeah.
I do feel like we should put out another disclaimer of this is not us encouraging you to take your drone skills out onto the streets. Just saying. Okay.
Yes. Or fiddle with your phone while driving. Please drive safely.
Yes.
Or spam people.
Yes. There's our list. I feel like it's pretty fully comprehensive at this point, so we cannot legally be held liable for spying, for drones in the streets, and for driving unsafely.
Yeah.
Perfect. I did see a question in regards to, so for example, if somebody is trying to capture a city that is particularly busy, like there are a lot of people walking on the sidewalk. Sorry, my brain just stopped. You got to see me buffer in live time there for a second. If there's a whole bunch of people walking on the street or there's a lot of traffic, things like that, would capturing data in those situations still work, or would it be more ideal to maybe wait until maybe nighttime or during a time of day where it is less busy?
Right. So capturing data would work. The only issue that you might run into is occlusion, right? If say you're driving next to a bus in front of a building, and if we never see that building, then we obviously can't reconstruct it. The bus moving around is not a problem. We remove all of the dynamic objects from the scenes, and as long as there is a reasonable amount of them, just so that they move in time, so that we can capture the entire scene, that should work fine. But again, we don't yet invent parts of the city that we haven't seen. If
Mm-hmm.
a part of a building has been occluded during the entire capture, then you're going to have a black texture or a hole there. Now, we'd advise, just so for the quality of the results, to do it when it's not too crowded, also when it's not too sunny, obviously, because currently we don't have any fancy shadow removal, and textures would tend to be shadowy. If that's something that's useful, then sure. But our recommendation is just do it in overcast weather, and then you can control the coloring of the texture in post-processing.
Mm-hmm. Yeah, that makes sense. So you would probably then also recommend for time of day, probably maybe around the middle of the day, not too bright, not too dark. Would you recommend ever capturing at night, or probably not?
No, night doesn't work for very specific reasons, which is we do not get a camera sensor, obviously trivialized a bit, works as by counting photons that hit it, and one of the problems that we have with any kind of computer vision on phones is motion blur if the phone is moving. Now, during the day, we can compensate for motion blur very well because we get a lot of photons in a very short amount of time. So the phone doesn't move much while we get the photons that we need. While at night, the phone moves much more. So nighttime capture is just motion blur all over the place, and it just wouldn't work. So our app actually has a feature that, based on your GPS coordinates, it figures out if it's day or night, and then just doesn't let you record if it's not bright enough.
I love that. So no point in wasting your time.
Exactly. I mean, each of the barriers we put into the app was something that we ran into issues with, and then had to solve it algorithmically.
Yeah.
So nighttime vibration, phone orientation, those are all things that typically people would omit. So we just had to, put in a lot of barriers.
Yeah. I personally love that because I know if that wasn't in place, I'm sure I'd be walking around getting the most unusable footage ever and just nothing would be working. So I think it's great that there's kind of this setup that pretty much guarantees success for use of the app.
Right. And, when we work with data collection associates who are paid for doing data collection. It's very unfortunate if they, show up after doing, let's say, 40 kilometers and all of the data is useless. So that is one of the reasons that we wanted to make their lives easier, so they don't have to think about whether the data is okay. The app will tell you, if it's now a good time to record and if you're doing it the right way. And one of the reasons that, again, we do only outdoors, because that is much simpler to do outdoors than indoors. Having an algorithm that is going to guide you to capture indoors is a very difficult problem.
Mm-hmm. Yeah.
And this has been user tested. This is not just me thinking about it out loud.
So it's not just you promising it. This is all verified.
Yeah.
Perfect. I do have one extremely important question for you that I saw come up in the chat a couple of times. So the people need to know, what is the dog's name?
The dog's name's Satya.
Oh, so cute.
And it's a she. Thank you.
Perfect. We had to know, we couldn't continue without, this was the burning question. We needed the answer.
Of course. I should have introduced her at the very beginning. Sorry for being rude.
It's okay. We can forgive you. We'll need a dog cam next time. Every time she runs by, it has a little highlight.
Yeah, of course. She's awesome. She helps.
Yeah. She's there to help with the dev, get all this going. We know who the cheerleader for the team is now.
Of course.
So there is a couple questions that I saw come up, wondering about if you were to capture the same area multiple times, separate days from each other, would you be able to layer that data on top of each other to potentially get a more complete picture? So for example, I know that in the demos, there were cars parked along the sides of the street. So obviously there were a couple holes where we couldn't see the buildings past those cars. So if we went back there another day when those cars were gone, captured the same streets, but maybe there were holes in other areas, do you think it would be easy enough to kind of layer that data to get the more complete picture?
Yeah, that sort of, I'd say, works out of the box. We have a feature to remove any sort of object that we do not want in the scene, and we typically remove cars. Now, with the setup that we use for this demo, if we were to remove cars, we'd be left with a bunch of holes, and it just doesn't look nice. So the reason we left the cars in is because we like them there. So if we were to capture on multiple occasions and then have cars move around, and each time we see different parking spots open, we could overlay those together.
That's awesome. So is that just a feature that anybody would be able to use, where they could decide whether they do want cars to be allowed in and out?
Yeah. So we have classifiers for some basic types of objects that you see in urban areas. So cars, pedestrians, road markings, roads, vegetation, trees. Trees are typically tricky. So any of those that you don't like, you can just remove automatically. Now, what's not magical yet is the hole filling side. In today's version, you're just left with a hole where the object used to be, which, okay, if you're an editor, you can fill relatively easily manually. But again, our whole mission is about doing everything automatically and providing the finished product to the user. So that is something that is on a roadmap to just, fill those holes where objects used to be.
Yeah. Well, I think it's cool that that is an option to begin with, though, being able to just remove those. I was going to say obstacles. I don't know if that's necessarily the right word for it in this case, but.
Yeah, so what is very important for our pipeline to work is to get rid of anything that moves, because those are the parts that are not very useful. So we have a bit of AI magic dust that does all of that object removal for us.
Hmm. That's really cool. I know I've said that I don't know how many times.
Yeah,
Take a shot of water so you can stay super hydrated every time I say that's really cool during the stream, but
I think I've been doing that.
perfect. Yeah, I just genuinely find this whole idea completely fascinating, and I'm just at a loss for words, which is not an easy feat to do. So props to begin with.
Thank you.
There are a couple other questions that I saw pop up. So when it comes to, because obviously it turns the video footage into a whole bunch of different photos, they were wondering how what that's based off of, how many photos are taken, for example. Is it a photo per frame of video, or how does that work?
1 per meter, roughly. So we need 1 image per meter. We use different sensors on the phone to figure out when you've moved that distance. When we get a bit more than that, it's not a problem. We filter on our end, but we also want to be mindful of your bandwidth and your
Mm.
storage. So we did a lot of experiments just to figure out how often should we snap the images, how big the images should be, and at what quality. So basically, if you're, say, a cab driver and you drive around all day, you are going to capture about 80 kilometers, 50 miles, which is going to fit into about 20 gigs, which means that it's going to fit onto your phone. That's reasonable. And you're going to be able to upload that overnight using your standard home Wi-Fi. So those are some of the trade-offs that we had to make. Obviously, for computer vision, more pixels, the better. More images, the better. But we just can't expect users to throw away all of their memory or bandwidth just to build these maps.
Right. Yeah, absolutely. Makes sense to me. There is, let me make sure I'm phrasing this one right where I saw this. Where was it? Oh, okay. So I think the way, and please correct me in chat if I'm not phrasing this correctly, but I believe they mean, would it be possible to use multiple devices to build one scan? So if you had a couple of people that wanted to walk around with each of them having phones, would they be able to kind of build all that data together? Or would it just be basically the same process and maybe just bringing in two different sources into the same Unreal file?
Yeah, that is the whole idea, like having multiple sources scan pieces as long as they overlap, and they have, significant overlap, say part of a street looking in the same direction. We can
Mhm.
build the same model using that. We also work with customers who have these specialized, capture rigs with multiple cameras, which is sort of a bit easier problem, but similar in a sense that it's multiple cameras building the same model together.
Mhm.
So the
Awesome.
overall idea is um, being able to merge data from any kind of phone with a reasonable camera into this one
Mhm.
big model.
Yeah. Awesome. That's just incredible. Speaking of a reasonable camera, what would you say would be kind of the minimum requirements of something that would work for this?
Right. So that's a great question. We've been experimenting with, I'd say maybe 50 Android models, and what we saw is that something like a Pixel 5 is
Hmm.
probably on the higher end. For that one, we can, guarantee great outputs. What I'm using is a Xiaomi A, I think 11, which is in the $200 to $300 range. So mid-range Android. Um, Anything 2019 and later tends to work okay. Obviously, newer phones are better because the OEMs just work on beefing up the cameras. But I think anything we saw from 2019, 2020, definitely onwards, is okay.
Awesome.
What tends
So
to
that is pretty accessible.
yeah, I mean, that's the whole point. Like, what tends to mess up the algorithms is when phones have built-in smoothing or built-in image improvement that we are not able to turn off through the API. So what we really need is just a raw image. But a lot of OEMs just, put in algorithms that make images look nicer to the human eye, which is very, very difficult for the reconstructions algorithm to deal with. So we've seen a few of those devices, but mainly in the sort of older range. So yeah, if you have a new Android phone, it's gonna be fine.
Yeah.
If it's not today, then we're working towards making it fine.
Yeah. It's in the plan.
Yeah.
Awesome. Well, I have some questions about what you would like to see come from this. So, maybe let's talk about some of the ultimate end goals. What are you hoping to achieve through this project of yours?
Well, we're really hoping to unlock applications for, say, real-time digital twins that we're not even thinking about today. Like I mentioned at the beginning, we have some ideas where this kind of technology can disrupt things that are already happening today, or maybe improve. Maybe it's going out on a limb to say disrupt. But I'm really curious to see what would happen if we put this into hands of creative and smart people. Like, if what we're building becomes a commodity, if we manage to make it a commodity, like, what can be built on top of this platform? And I think that's very exciting because you never know. We have so many examples of, things being built with one purpose or a few purposes in mind, and then going in a totally different direction that nobody at the time when it was built could have imagined. So that is what really gets me excited about this tech. And then there's also just pushing the state of the art in 3D reconstruction, just improving, on the existing science of photogrammetry and 3D reconstruction through very, very practical use cases.
Yeah, absolutely. I know that for me, I'm excited to see all of the different possible ways that this could be used, right? Because, I mean, just off the top of my head, I can already see how this would be applicable in different industries. And I'm sure, like you were saying, there's plenty of other far more creative and far more intelligent people than me who have even broader usages that they can think
than
of.
me as well.
It's then both of us. There's going to be someone somewhere. I think that's just truly incredible. I think some of the end results are going to be stuff we wouldn't even be able to guess would happen. So I think that's really
exactly. I think that's what really gets me up in the morning. Just thinking, okay, there is a future where this tech is commoditized, to say, where it's really mainstream. How far in the future it is, we'll have to see. But at some point, everything that we're describing here today and that we're seeing glimpses of a product is going to work magically. So just thinking about that solution and everything that it contributes to is kind of exciting to me.
Yeah, absolutely. So there's a couple of maybe slightly more technical questions that have come in as well. So for example, they're wondering, what is the general poly count of one of the meshes that gets brought into the engine?
Oh, it's huge. It's in the hundreds of thousands. um, and it hasn't been optimized in any way. So right now we just import them and look at them and inspect the issues, just focusing on the visual look and feel. Our approach is, once we have the quality that we want, that is when we optimize for performance and usability. So I can definitely say there's a lot of room for poly count improvement. There is a lot of low-hanging fruit, but I think the quality needs to improve a bit more until we start thinking about, optimizing this for either mobile devices or any kind of a perf-heavy application.
Right. Have a more complete picture before you worry about then condensing the picture down, for example.
Exactly.
Makes sense. Do you think it would be possible at any point to kind of combine what it is that you're doing here and adding in some procedural elements that exist in the engine? So, for example, we have things like Quixel Bridge, which has megascans, some 3D assets that have already been scanned in, things like that. Do you think it would be possible at any point to sort of have the two crossover, where if you don't want to scan in our lollipop trees from walking around, for example, and instead replace it procedurally with an already made foliage tree, do you think that would be something that could be possible at some point?
Yeah, so the original, I think, in the Mega Grants pitch that we put together, we had this idea of first building the 3D models, then doing the semantic understanding to know what kind of surfaces these models are built from, and then importing those types of surfaces from Megascans and blending them to achieve sort of physical PBR quality. I'm actually sad to say that our initial idea did not pan out too well. I'm personally not too happy with how we solved that one. So that is something that we're actively working on. I think it's very important and very useful to have the physical properties of these textures be correct. Now, there are things where we do mesh with Megascans pretty well. That is trees, poles, and sidewalks, sort of these linear structures that we can extract pretty easily. And I haven't showed any of those demos today, but we can replace those with Megascans very effectively. So I'd say there are some scenarios where that approach makes sense, and there are some where we need to go back to the drawing board.
Yeah, that makes sense. It sounds like a huge undertaking to have something that would seamlessly kind of combine all of these different elements. So I think it's impressive that you have the bits that you do have, where it can include in some of the megaskin textures that are already in the library, for example.
Well, what we've seen is that if a designer would start off with the output from our pipeline and then use Megascans element to augment it, that can look and feel pretty good.
Yeah. So we have the building blocks, right? There's the framework is there.
Yeah, yeah. We just have to figure out, the details in edge cases. I think there's
Yeah.
something there.
Yeah, absolutely. I think that's going to be so cool to just watch develop over time as well. Um,
And I also think
I
that
am.
our kind of tech can blend in with it's sort of a natural uh, way to combine with Megascans, because Megascans is doing very, very high-end photogrammetry on very specific objects, like the way they they scan and build these models is high-end, very well trained, and a very thought out process, where we're trying to go for scale and a lot less trained users. So there is sort of a spectrum of quality and scale that I think Y-Drive and Megascan sort of complement in.
Yeah, absolutely. It's kind of solving different parts of the same equation.
Yeah, that's a good way to put it. Sorry, I interrupted you. There's a bit of a lag.
No, it's fine. What you had to say was far more important than me. I mean, everyone here is here to hear from you and about your project, so no worries about that.
All right.
I do have a question about something that is gone now. I had one lined up, and it's just not going to be here, I guess. So let me take one from chat while I try and reboot whatever was going on there. But oh, this is actually a fantastic question. How would it handle seasons? So, if somebody wanted to capture their street in all of the different seasons, would it be able to handle all of those different types of textures? So, a snowy street versus one with leaves falling on it, for example.
No, that's the sort of short and sweet answer. Not today. I think this is a more complete answer. Huge environment changes are not handled very well by citizen today, for many reasons. But that is something that is a very important challenge. So when it comes to generally to mapping and localization and 3D scanning, so that is something that we're thinking actively about. But today, if you were to scan the same street in just very different environments, such as sun and snow, you would get two totally independent 3D models, which you could work with, but you would get two models.
Yeah, that makes sense. Or they could maybe be sort of layered, but it would end up ultimately as just two separate things.
Yeah, I'm sure there's some material magic that a skilled UE developer could pull off to make those two work together. But what Citizen would produce right now are two independent models.
Mm-hmm. Yeah. Well, I mean, technical artists, as far as I'm concerned, are wizards and magicians of their own right. So they could probably get anything to work with just a random idea and somehow throw it together. So
Yeah, I'm sure there's enough of them, looking at what we produce and saying, I could work with that. Yeah, it's not perfect, but I can do my magic there.
always a starting point for someone. So I do want to talk a little bit more about your journey with the Mega Grant, actually, if you're okay with that, just so that I can give a tiny bit of a shout out to our incredible Mega Grant team, specifically to Sandra, if you're watching this. Love you, girl. But I'm curious about at what point in your journey was it that Y-Drive decided you wanted to reach out for a grant, and how has it ultimately impacted the development of this project so far?
Oh, it's all thanks to Uros Sikimic from Trilateral, the Epic's daughter company that's building MetaHumans. He's the one who brought attention to us to Mega Grants when we were just starting out. He helped us out through the application journey, and he's sort of been our chaperone throughout the reporting process. Once we went into development, the whole Mega Grants experience was very elegant in terms of Absence of, I was gonna say in terms of bureaucracy, but in terms of absence of bureaucracy, it was the pitching process was extremely elegant. We put together a pitch deck with AV demos, our thinking about Citizen, which was very early at the time, um, and submitted it. We did wait a while. It took a few months to get some response, but to get a response back, and then finally to get a positive response. And as once we went into execution, um, we sent back a demo every month and received back an email saying, "Oh, this is awesome! You guys are making progress." It was even encouraging. Um, Unlike like most grant processes. So I think the whole experience was very, very positive.
That's good to hear. Would have been really bad if I asked that. It was like, oh, it was the worst. Terrible service.
Yeah. No, it was really it was great. And again, shout out to Sandra and Urosh.
Yeah, awesome. Well, I have just a couple more questions for you, just a few. I really want to
Shoot.
know. This is the question that everybody hates to have asked, and it makes me want to apologize for asking it, but I am actually interested in the answer. So,
I'm very
where
nervous right now.
where do you see Y Drive and City Synth in 5 years? The classic.
Right. Well, I think it's actually very simple. I think in 5 years, we should be a product with millions of users. Everything I sort of explained that we're working towards, I do expect to turn into this amazing platform that allows people to build on making applications that we're not even aware of today.
Mm, absolutely.
So having,
Yeah.
say, having data coming in daily from every continent, say, um, being in sort of a position where Mapillary is when it comes to street side imagery, but building that up into a 3D model in a way that we talked about tonight, with applications that we discussed and many more, is sort of where the North Star for Y Drive is. Now, is that 5 years? I don't know. Um, Seems reasonable, maybe a bit more, but we'll see, and we'll do our best to get there.
That's awesome. I love hearing just the general roadmap and the ultimate goal of where it's going to land and the forward markers, you know?
Yeah, I think that is one thing that Y Drive has been very. We've been called stubborn on the North Star for our tech, and startups are known to pivot much faster than we do. But I think that's the kind of stubbornness that you have to have with a very hard problem like the one we're trying to solve. You have to respect the problem, give it time, put in effort, and it should pay off.
Yeah. I feel like it will. Just from the bits that you've shown me, I really do feel like this is going to have its own very special place in not just the photogrammetry market, but multiple other industries to just kind of build off of.
That's Well, thank you for the kind words. That's always great to hear, and I always enjoy like showing people what we're up to, and just hearing feedback. I think that is how you learn and evolve.
Yes, absolutely. Speaking of which, so for any of our viewers who are interested in CitySynth and are desperate to try and get their hands on it and play around with it. Will there be any type of beta that would be open for testing, or what's kind of the plans around stuff like that?
Yeah, we once we sort of figure out some of the scale issues, some of the technical issues in the following, I'm guessing months. Saying weeks would be too optimistic. We do plan to open up a beta for a limited number of users who think they can do magical things with Citizen, so they can try it out.
That's awesome. So keep your eyes out, everyone. Where would they be able to follow you and this progress, where they can keep up with that if it's something they're interested in doing?
Yeah, I've been promising an update of our website, Y-Drive AI, with all of the Citizen stuff. We have a Citizen app on Play Store, which I think will be an okay source once more features show up in it. And our LinkedIn is also a place where we occasionally announce news of this kind. So those three might be okay.
Awesome. Fantastic. Well, there we go. So we know exactly where to keep up with all the latest and greatest updates. And hopefully maybe a couple people can get their hands on it and play around with it.
Yeah, and I'm really excited to see like what people would, what users would make, what our tech and this capability inspires people to think of, and what the end result is.
Yeah, absolutely. I'm excited too. I think the sky's the limit, to sound as absolutely horrifically cheesy as possible. Endless possibilities with this tech, and I cannot talk it up enough. Truly, it is absolutely incredible work that you and your team have done so far. And I personally, and I feel like I can talk a little bit on the behalf of some others as well when I say it's so exciting to see what the trajectory of this is and to see where it goes.
Well, I thank you again for the kind words. I hope somebody from the team is watching us at 9:30 p.m. So they can hear it from the horse's mouth.
They can watch the video afterwards if they need to. Get some sleep, please. Yeah. Well, with that, is there any other last statements or comments or remarks you want to make sure that you say about your project?
I think I've talked more than enough about Citizen. I just want to thank you again for having me. I want to thank Epic for the Mega Grants opportunity, and everybody who's been involved and helped with the process. You guys have been awesome. And Dan, you did a great job on your first day. Kudos.
Yes, everybody give a warm welcome to our new tech guy, Dan. Today was his first stream, and I think he did a fantastic job. So shout out to you. Splendid job. All right. Well, with that, I want to thank you so much for taking the time to come and chat with me today and chat with all of our viewers. It really is, again, just incredible work that you're working on. And I very much appreciate you taking the time to come and talk it through with us a little bit.
It was truly my pleasure. Hopefully next time we can show some of the work done by users and not just demos coming out of Y-Drive. Until then, yeah.
Absolutely. Well, just like I said, we'll have you come back on in 6 months to a year, and we'll see all the new updates.
Will do. Thank you, Tina.
Absolutely. And thank you, everybody who came to watch the show as well. Obviously, this wouldn't be what it is without you and your input and your questions. So thank you all for being here and interacting. It is always a joy to have you here. We post all of our streams in video format that can be viewed on demand on both our YouTube and Twitch channel, Unreal Engine. Don't forget to keep up with us at Unreal Engine on all social media, as well as come say hi in our forums where you can get all the latest news and also find all of the links associated with today's stream as well. But with that, once again, thank you so much, Philip, for coming today. And I will see all of the rest of you next week for our next show. But thank you.